Okay, good evening. It is day 65. Five. Um, it's very late, so we're only gonna do one leak code today. And I'm probably just gonna intro this, pause, and then I'm doing something, and then we'll do that one leak code. So yeah. Mm-hmm, mm-hmm. Yeah. Sorry about the it hasn't been the best videos the last couple days, but like today should have been a lot better, but I woke up very late today. I stayed up a lot later than I thought I was yesterday, and so I woke up a lot later than I thought I was today. Um, oh well. Um, Still applying to stuff, still, doing doing what's got to be done, but we will yeah, we'll do the one leak code today. That's the only plan I really have for today. And then tomorrow I have a 9 a.m. computer architecture. And then I know I have like a homework due on Wednesday for a class. I think I have other classes tomorrow as well, but we'll see what's what tomorrow looks like, and then I don't know when I'll record tomorrow. I don't know if after I might do like after the 9 a.m. I'll come back, record, and then leave for my other classes, and then that's it, right? Record between. I should actually check what those classes are. Um, uh, do I have it labeled somewhere? One second. Uh, I just brought it to here, and we'll look at it from here. Um, Computer system principles is on Mondays at 2:30. Gosman Laboratory, room 20. Okay, I know where that is. That's main building. Um, Algorithms is also Mondays and Wednesdays, starting at 4. Okay. And the computer architecture is Monday and Wednesdays, 9:05. So, okay. So the plan is going to be I have this from 9 to 10. I can probably be back here by 10:45, 11ish, and then from 11 to 2, 11, yeah. So that little notch of time between getting back from computer architecture and leaving for computer system principles will yeah, we'll record there, and then I'll go to those classes, and then the rest of my night will just be whatever I want to do, whatever I have to do for the rest of the night. Um, but yeah. Okay. Yeah, not bad. Um, so that's the plan. And in most of these videos now are going to be 1, 2 lead codes and then just schoolwork. So that's how I'll be occupying. And I just want to aim above an hour, between an hour and 3 hours of video. That's a perfect amount of time during the school year. That's enough to do a lead code or two at the minimum, and a maximum of doing a lead code or two and then studying for one class for like a solid chunk of time. This is every day. So if I can study for every day for at least 2 hours, I'll have a great semester. So yeah, that's the plan. Um, one second. We can start the lead code, but I might have to pause. And even if this lead code takes me 10 minutes to do, we're ending at 10 minutes. Um, let's see what this is. I'll close that. Charles Bart. Yeah, that trade, bro. That trade with Luca and AD. Crazy. Anyways, increasing triplet subsequence. Given an integer array nums, return true if there exists a triple of indices I, j, k such that I, whatever, and nums at I. If no, okay, so 1, 2, 3. So this needs to be less than this. So this needs to be less than this. And this needs to be greater than this. So technically you could have like this index and then this index and this index, right? Right? But like here it would never exist because you can never find if it's decreasing, you'll never be able to find that. But like technically 1, 3, and 4 would be valid because okay. So it's not even like a sliding window thing, right? Because it can be any size. So that's actually kind of tough. What about okay, yeah, 3, 4, 6 works, but yeah. So you have to find, something you could do is you could find the absolute max value in the array and its index, right? And then from that point, you can just go to the beginning half with like from a pointer and just go and see if you can find an indice that is, you know, less than that one and then a value that's less than that one. And then if you can't, there could be a situation where you have like an 8 and then like I'm trying to see if there's ever a situation where you'd want to like switch off of that 8, right? I mean, brute force is you start on the right side and you just test every number. And wow, that's a big time complexity. You look at this number and you check it to everything else in the array. Actually, you're only going until you find like any case, right? So technically, we could take. You know what would be really cool is if we. Hmm, is if I like if I made a dictionary that was sorted from like least to greatest, and the key was like its actual value, and like the value was its index. And then you could easily just go through in blocks of 3 in the dictionary and just say like, are these 3 keys? And if the keys are the actual values, is it blah blah blah, and is it blah blah blah? I'll be right back. Ah, we back. Okay, so let's just do. I'm trying to think here. I'll bring up TLDraw because what I was thinking was, um, is so we have, let's say, 2, 3, 1, 4, 6, uh, uh, 5, right? So this would be valid, right? 2, 3, 4 would be valid. So what if we did something where we made an array of all the values, right? In which it went like 1, 2, 3, 4, 5, 6, and next to it was its index. So its value is its index. So 1 is index 2, 2 is index 0, 3 is index 1, 4 is index 3, um, 5, and 4, right? And so we say, okay, let's look at this. Is this valid? Well, yeah, this is valid, this is valid, this is valid. Is this valid? Is 1, is 2 less than this? Nope. So we slide the window to these three. Okay, is 0 less than this? Yep. Is 1 less than this? Yep. Is 2 less than this? Yep. Is 3 less than this? Yep. Valid, return true. So I think that could be quite a good solution. So we'll have a dictionary. We'll just call it that. We'll have a dictionary. And what we want to do is we just want to turn nums. We want to say for index and each in enumerate nums. And we're just creating for everyone. So it's going to be dictionary at index or at each is equal to index. Okay, and then I want to do how to sort Python dictionary by key. It might just be dot sort. Oh, no. Just sorted. So I can just say right, and then I want to just look at for start in range of the length of nums. That'll be 5. So that'll be 0 through 4. But we want to do up until 2 minus 2. Minus 2, I think. And we just want to say if actually, why am I doing it? Just do it by index. Oh, no. Wait, what am I saying? No, I want to do it by each because then we're sorting it by each. Then we'll have it. So this is the value and this is the index. So we know this is always valid. All the values are always going to be valid. So we only want to look at the values. So we want to say Like if new dictionary at start is, if that value is less than new dictionary at start plus 1, if that value is less than new dictionary at start plus 3, right? So if the index is less than this and this and this, right, return true. Otherwise, just don't do anything. Just move to the next one. Kind of all we want to do, right? Now there's the edge case of like, let's say we have, I mean, if num's ever, let's just try this. Let's just see what happens. Unindent does not match any outer indentation level. Oh, what? Why did that happen? Okay. So output was true. Now why would that be? Let's print, sorry, let's print. Actually, what did it? Can you do that? No, you can. Well, actually, it's doing. How would I? What, for key value in dictionary.items? That's what I wanted. I can just do this in. Right. The error. Yes, I know sorted is returning a list, so you can do create a new. So for key in dictionary. Out of bounds. If new dictionary at start, which is 0. Okay. Maybe it's -3. Nope. What is a key error? If new dictionary at, oh, there's no 0. Oh, that is true. If I do the values like that. Well, yeah, that is true. Ooh, that is true. I mean, I could swap it afterwards, right? Like, is there an easy way to swap keys and values? So for 102, so for each value, the value is going to be key for key. So for key and value in original. So the value is going to be the key in key value. Okay, I see. So we're going to do that. Our new dictionary equals that. Swap dictionary equals that. Not whopped. Let's try that. Original. Oh, how about that? 6. What? Why is the index still this? One second, I'll be right back. I'm back. Okay. Did I mess this up? Originally, what we do is we say the key is the actual like value here. But then we want to reverse it afterwards and say the value is the index and the key. Oh my God. No, it is correct, but it's saying, so when I say at value like 1 right here, so we're looking at this, which are the values, right? 0 through 6, yeah. So we're saying, okay, is this, and this valid? These are always going to be valid. So is this, and this valid? No. Is this, and this valid? No. Is this, and this valid? No. But this does because of 3, 4, and 5. Is this whole approach is just wrong, isn't it? If we sorted this, 3, 4, and 5, index 1, 1, 2, 3. So 0, 4, and 6. Oh, yeah, this approach is wrong because of, yeah. Yeah, okay. Oh, man. Oh, we have to scrap this whole thing. Damn. Okay. Okay, so now I could try with like, well, what would the absolute brute force thing be here? You would take the first uh, number, and then you'd find the second one, and then from there you'd go and you'd try to find a third one. If you can't, then you're going to go back to the second one, keep incrementing it, and seeing if you find another value that is bigger than that first value. And if you do, then you check the rest, whatever, you keep going. So in code, that would literally be for each in nums, for each in, sorry, for num1 in nums, for num2 in nums. I love the triple for loop, isn't it? Okay, what am I doing? This is stupid. This is literally saying, like, if num1 wait, is this actually like just fully correct here? Because okay, we'd have num1, right here, and then we'd have num2, and so which would be right here, and then num3, and so num3 would go through, and you'd say, let's just run it. It returns true. Why would it return true? Three, 4, and 5. Okay, I need to make a clause that every single time for num2 in range of, okay, num1 is going to be index num1 enumerate num. And then this is going to be range from index onwards. But I'll be right back. Back again. Just to the length of nums. Sorry, and this should be, if we're doing in range, it should be yeah, let's submit it, guys. This will definitely not be a time limit exceeded. Definitely not. The triple for loop, that's so efficient. I actually just got a wrong answer. 1 second. Okay, 2 wrong attempts. But at least this one, you know. What could it be? I don't know why these array ones are tripping me up. We got any hints around here, guys? Got any hints? Huh. Well, there's got to be a way to like eliminate stuff based off of index, right? Wouldn't also 146 work here? I'm telling you, I think what I do is I put a pointer on the right side and I go and I find and I find just any number and then I like go out and I try to find like another one. And then if we fail, then that second pointer keeps moving until it finds another thing that's smaller and just so on and so forth, right? You know, you could do something with like memory, right? Is you could do like if you like cached it or something where it was like, okay, if we check 640, which I mean is correct, but like here, if we checked 1, immediately ends. 2 immediately ends. 3, it would just keep moving until well, keep moving the second pointer until it got all the way through, and then I go here, and then I keep moving. But again, that is another. That was what we were doing. That's a triple for loop. I might have admit defeat on this actually. I don't know. min1 equals integer dot max value for n in nums. This is okay. So min1 is infinity. So we're going to two infinity values for n in nums. If n is less than or equal to min1, min1 is equal to n. Else if n is less than or equal to min2, min2 equals that. Else, so if n is greater than or equal to min1, and min2 is greater than or equal to, or if the current value is greater than or equal to 2. Oh my God, wait, that is really smart, right? If you have two values, like let's say you have like here, right? Originally you would set n min1 is 5, or let's go here. Min1 is 2, then you'd go to the next n and you'd say, okay, min2, min1 is 2, min2 is 1. And you go to this one, you say, okay, is min1 less than or equal to min5? It is. So now min1 is equal to 5. Okay. Then you go here and you say, is this less than or equal to min1? And it is, right? Wait. Let me look through this one more time. Two values set to infinity. For n, so let's look at this. No, not that. Third case. Okay. So we're at 2. Is this less than or equal to min1? It is. So we set that to equal to 2. Then we go through again. For n, is this value less than or equal to min1? It is. So now min1 is equal to 1. We go through again. We have 5. Is this less than or equal to 1? No. So we go here and we say, okay, is n less than or equal to min2? Yep. So now we have 1, 5. And then we go through again and we go to 0. Is this less than or equal to? Yeah. So now we have 0 and 5. Then we go through again. Nothing's going to be less than this. So then we have 4, right? So now min2 is equal to 4 because it was less than 5. Then we go through again and it doesn't hit this. It doesn't hit this. So it has to be true because it's not less than either of these. Breaking it. My only question is, one second. My only question is though, is it's like, what if you found something next that was like the value was, oh, because if it was less than that, then it doesn't matter if the next value after that would be greater. Okay. I see. So min1 is equal to, what was it? Float infinity. Let me just make sure I'm right on that. Yeah. And min2 is equal to float. Sorry, I need to sit up better in this chair. Is equal to another float infinity. For n in nums, if n is less than or equal to min1, then then that value is equal to n. Else if n is less than or equal to second minimum, then that second minimum is going to equal n. Else, return true. We get through the whole thing, return false. They're like, what are you on? Okay, yeah. Okay. Um, that's a pretty cool solution right there. I like that solution. Um, where did I like falter here? I think the whole idea, I think an idea that I need to get more comfortable with is the idea of keeping track of something, or like in this instance, right? It's kind of like a rolling thing. Like we know that if we find like a 3 and then we find a 2, we know we can just set it equal to that, like that first value that we want. We can just set it equal to the 2 because there's going to be no values that will be valid afterwards that won't be valid with the 2, with that were valid with the 3 that would be valid with the 2. So you can just have a rolling minimum on that minimum value. And you can do the same with the second one, right? Um, if you have a value that is greater than the second value, right? And you go to the next one and it's less than the current value, you can just, change that to that. Um, because it won't affect the third value. Because even if we're at the last element, right? If it's less than the current value, then we'll never get a return. Um, so yeah, just getting a little more familiar with that. I think something I want to do this week is look at a hardware project we can start. I really want to build something. I really want to do some embedded stuff. I'm going to be in computer architecture working on, chips and instruction sets. I kind of want to build like a little mini like pocket device or even like a mini computer. Call me crazy, but I think it would be a really fun project. And I think it is where I want to kind of take my career towards. I think I want to step away from just software. I think I've kind of made the decision of I really want to get working with hardware and working with embedded systems and system programming and computing and stuff like that. That stuff sounds pretty cool. Opposed to like full stack and networking and stuff like that. I'll still be doing that stuff because it's really useful. But yeah. So sorry for the really bad video, but they should be a lot better this week because we'll be working on schoolwork and computer architecture stuff. But yeah. So have a good night, and I will see you tomorrow between classes. Bye.